Good morning, students. Today we are discussing about methods of determining the order of reaction. Okay, so in this theory, we have discussed about order of reactions. Okay, this method consists in carrying out the reaction with known quantity, quaternary reactants, and determining the amount of reactant consumed after different intervals of time, and substituting the data in the equation for first and second order reaction. What it happens means this method consists in carrying out the reaction, okay, with known quantity. Okay, quantities means with known quantities means we know that the type of quantities, how much, 10 ml, 20 ml, 30 ml, where it is. In this reaction we can source to reactants which is rest to products, okay, and outside byproducts. This is catalyst. We know that these reactions how much percentage, we know that reactants, and determining the amount of reactant or how much amount we can determine, and consumed after different intervals of the time, and substituting the data in the equations for first and second order reaction. What should happens means rate equation for first order reaction K equal 2.303 by T log C naught by C. We know that, okay. So to rate constant K equal to 2.303 by T log C naught by C. You know that in that C naught by C, we can substitute 2.303 by T log A by A minus X. We know that in the previous class also we have discussed about that C naught by C equal to A by A minus X, okay, is a perfect constant term, so that's why we can take A minus X. This is the initial concentration, so we can take that A. Integration of A to A minus X, okay, we can take integration of A to A minus X. What should happen in this constant K? We should substitute A minus X, this like this, okay. What is K equal 2.303 by T log C naught by C. So 2.303 by T log A by A minus X. So rate equation for second order reaction. Okay, second order reaction rate equations. What is this? K equal to 1 by T, 1 by C minus 1 by C naught. Okay, this is why, because we know that log A by B equal to how much? Log A by B. It can be written as log A minus log B, okay. This also we can write log A by B. We can write this log A, log B. Log A plus log B we can write as log A. Okay, students, belongs to the, so listen carefully. Log A by B we can write as log A minus log B. This is the integral formation, okay. This log AB into form, this was written as log A plus log B. This is log AB, this is log A by B. These two are from inter onwards we can write, but you are from BBC, so you don't have this type of. So in this we can take K equal to 1 by T, 1 by C minus 1 by C naught, okay, this one. So our K equal to 1 by C, what happens? C minus C by C naught means A by A minus X. So C, in place of C, what should we take? A minus X, and C naught 1 by A. So the equation which gives constant value of K, the velocity constant indicates the appropriate order of the reaction. Okay, students, first onwards this method consists in carrying out the reaction. Carrying out reaction means when we are taking reactants and catalyst, what it forms products. That is a carrying out reaction with known quantities of reactants. Okay, known quantities means we know that about that quantities very well, and to determine the amount of reactant, okay, consumed after different intervals of time, and substituting the data in the equations first and second order reaction. Rate equation for first order reaction equal to k equal 2.303 by t log c naught by c. So k equal to 2.303 by t log a by a minus x. We know that. Okay, where should it comes means in second order reaction we know that time intervals. Okay. In that rate equation for the second order reaction, what happens? K equal to 1 by t 1 by c minus 1 by c naught. Okay, or otherwise we can write also k equal to 1 by t 1 by a minus x minus 1 by a. Okay, and this is written the equation which gives the constant value of k. The velocity constant indicates the appropriate order of the reaction. Okay student, this is so in that rate equation second order reaction k equal 1 by t 1 by c minus 1 by c naught. Okay, this is the equation. So in that the equation which gives constant value of k, the velocity constant indicates the appropriate order of reaction. Okay, this is the velocity of this total rate constant gives the velocity of the order. Okay, next one. So various rate equations can be tested by the graphical method. Graphical method means we know that should also be discussed about graphical method. A minus x or c naught by c. Okay, this graphical method is from origin to straight line. Why? Because in this a proportional to or c proportional to c naught, what happens to c where c decreases, c naught also decreases. Where c increases, c naught also increases. This is in graphical method. Graphical method where the point comes from origin to straight line. This forms a straight line. Straight line means where c increases, c naught increases. C naught decreases, c decreases. Directly proportional to. Otherwise, c not direct inversely proportional to c. What should happens? So c naught is where c naught increases, c is decreases. Where c naught decreases, c is increases. This is inversely proportional. This is directly proportional. Okay, students. So since the initial concentration c naught or a is constant for each complete experiment, the equations for first and second order reactions reduce to k equal to 2.303 by t log a minus x plus constant. Okay, this is 2.303 by t log a minus x plus constant. K equal to 1 by t 1 by a minus x plus constant. Okay, the first order reactions will give a straight line. Okay, when log a minus x is plotted versus t. Okay, what happens? It is in that also you can write that. So first order reaction will give a straight line. Okay, this also same like this straight line. When we take second order, first order also this is straight line. But in first order, slightly moving a straight line to downward position. Why? Because and in first order reaction we know that reactance is directly proportional to products is not there. Why? Because reactance is inversely proportional to products. In between mediator catalyst, this catalyst is very dangerous to reactants. So that's why this is some slight inversely proportional to products. So this is also like this second order reaction. Second order reaction also same, origin to straight line. This is origin to straight line. What happens? It is t a minus x. So t means time with respect to constant. So these two are very close to rare conditions. So in that rare conditions we can take a minus x and t. Okay, time and concentrations. What happens? It is a minus x proportional to t. By means in this a minus x, concentration increases, time also increases. Concentration decreases, time decreases. This directly proportional means where one is increases, another also increases. Where one is decreases, another also decreases. This is the graphical methods of reactants. And while the second order reaction will give a straight line when 1 by a minus x is plotted versus t. Okay, what happens is second straight line also will give a straight line. Why? Because this is also same. This t 1 by a minus x. What happens? This also take 1 by t. So what happens? This is also inversely proportional or directly. Why? Because this is inverse position. This is also inverse position. These two are inverse position. We can take this two are inverse position. What happens? It is gradually decreases to increases. So, okay, this is the straight line. This is also straight line. What happens? Where a trace equation can be tested by the graphical method. Since the initial concentration C0 or A is the constant for each complete experiment, the equation for first and second order reactions reduce the k equal 2.303 by t log a minus x plus constant. Okay, this is the equation. So k equal to 1 by t 1 by a minus x plus constant. First order reactions will give a straight line, okay, when log a minus x is plotted versus t, while second order reaction will give a straight line when 1 by a minus x is plotted versus t. Okay, next one, half-life method. Reaction change methods. This is also called reaction change methods. What should happen? As discussed earlier, half-life period of a reaction, that is the time required to convert the original concentration of reactant to half. Okay, converted the original concentration of reactant to half of different orders. Okay, what should happens? Discussed what we discussed earlier. Half-life period of a reaction. Half-life means we know the t half. Okay, t half 2.303 by t of log C0 by C. Okay, we know that. That is half-life period reaction. That is the time required to convert the required concentration of reactant to half. Half means when we take 50%, so in that 50% we can take half means 25%. So reactant to half of different orders. So for first order reaction, what should happens? T half equal to 0.693 by K. Where is total? We can take this total reaction. In that we can take half solution. What happens? It is 0.693 by T K. Okay. T half equal to 0.693 by K. Okay. For second order reaction, what happens? T half equal to 1 by K. So what should happen? The half-life of period of a reaction is independent of the initial concentration. Okay. Half-life of the initial concentration of the reactions. Okay. Next one. For first order reaction, what happens? Inversely proportional to the initial. In case of second order reaction, in general, T proportional to 1 by a n minus 1 means n minus 1 means when we take 100 times, what happens? 100 minus 1, 99 times only. Okay, this is first order reaction. T proportional to inversely proportional to a times power n minus 1 times. Okay, this is the order of reactions. Next one, Van Tapp's differential methods. Okay, next one we discuss about Van Tapp's. What is Van Tapp's reactions? Well, the rate of reaction varies as the nth power of the concentration of the reactant. Okay, what happens? The rate of reaction varies as the varies means flowing. Okay, the rate of reaction varies as the nth power of the concentration of the reactant. Concentration of reactant, where n is the order of the reaction. R equal to minus dc by dt equal to kcn. Okay, this is the equation of the Van Tapp's reaction. So what is R equal to minus dc by dt equal to kcn. Okay, kcn. So in that kcn, what happens? For two different concentrations C1 and C2, the rates R1 and R2 can be written as what happens. In that rates also change into concentration change. What happens? R1 equal to minus dc1 by dt equal to kc1 power n. Okay, this is equation 1. Next, R2 equal to minus dc2 by dt equal to kc2 power n. This is equation 2. Okay, so in that we can take I'm taking logarithms. Logarithms means logs 1 and 2. What happens? Log R1 equal to log k plus log c1 power n. Okay, log R2 equal to log k plus n log c2n. Okay, in that way we discussed on like in that total we can take log values. Log values means in previous also we discussed about log this log applied for kc1 power n. So this is seems to like this one, log ab. A means k, b means c1. Okay, this log ab. Okay, what should we take? Log k plus log c power 1 power n. Okay, this is right, written at this line, this way. Why? Because we know that log ab equal to, what happens, log a plus log b. They are also same, log k plus log c1 power n. So in the two, log k power n we can write as n log k. Okay students, this is also one of the formula. What happens, log k power n equal to n log k. What should happens, log c1 power n. So this is write as log k plus n log c1. Okay, next second equation, log k plus n log c2. Okay, this is first and second, third and fourth equation. Third equation, what is the third equation? Log k plus n log c1. This is the third equation. Log r2 equal to log k plus n log c2. Fourth equation. This subtract equation 4 and 3. Okay, this subtract means minus. Okay, subtract equation 4 minus 3. Okay, what happens, it is log r1 minus r2 minus, okay, first this taken. So r2 minus log r1 equal to, what happens, log k plus n log c2 minus log k minus n log c1. Okay students, what happens, this equation we will write first, and the next one minus log r1. So first log k plus n log c2 we can write. So next minus log k minus n log c1. What happens in this, log k cancel. So what happens, log r2 by r1. Okay, why? Because log a minus log b means log a by b. So next n log c2 minus n log c1. What happens in this, log r2 by r1 equal to n common తీస్తే ఏమైంది, log c2 by c1. Okay, total equation log r2 by r1 equal to n log c2 by c1. This is the equation of one-half differential methods. Okay, this is the one-half differential method. What happens in this means the rate of reaction varies with as the nth power of the concentration of the reactant. Okay, nth power of the concentration of the reactant, where n is the order of the reaction. We know that R equal to minus dc by dt equal to kc power n. Okay, what happens in this, for two different concentrations of C1 and C2, the rates R1 and R2 can be given as R1 equal to minus dc1 by dt equal to kc1 power n. Okay, this is equation 1. Next one, R2 equal to minus dc2 by dt equal to kc2 power n. This is equation number 2. So what happens on taking logarithms 1 and 2, what happens, log R1 equal to log k plus, what happens, this is applied to this. So log k plus n log c1. Okay, first third equation. Next log r2 equal to log k plus n log c2. Okay, this is the fourth equation. Okay, this is the third equation, this is the fourth equation, this is the first equation, this is the second equation. Okay students, what happens, to subtract equation 4 minus 3. Okay, log r2 minus log r1, this is log r2 minus log r1. What happens, log k. Okay, log k plus n log c2. This is first we can write. Next one, minus log k minus n log c1. Okay, so what happens in this, log a minus b, log a minus log b. What happens, log a by b. Okay, and what happens, log k cancel. What happens, log c2 by c1. Why? Because means in this log c2 and log c1 means log a minus log b. Okay, log a minus log b. What happens in this, we can take log, so a by b. This is the equation, okay, log a by b. In that same also log c2 minus n log c1, n common, what happens, log c2 by c1. This is the equation, okay, this is the equation, okay. Student understood what happens in this? Total r equal minus dt by tc equal kc power n. In this we can apply only log values, okay, log values. This is most important, and in exam also ask very well. So log we can apply. So this is a log values, and this is the equation of log r2 by r1 equal to n log c2 by c1. Okay student, this is the equation of the log. Good morning students. Today we are discussing about rate constant of second order reaction having two different reactants. So in that first we have to take second order reaction. What is second order reaction? The reactants which having the products in the form of direct or inversely. At the same time, the time is inverse position. That is called second order reaction. In the second order reaction, we have rate constant of second order reaction having two different reactants. In general, the second order reaction of the type may be written as, what should we take? A plus B such products, okay. These products, these are all these two are A and B are called reactants, okay. Reactants gives us to product. So in such reaction, again there are two possibilities. First one, when both the reactants have same initial concentration, that is, we know that same initial concentration means reactant A equal to reactant B. Yeah, either A equal to A or A is equal to A equal to B or B equal to A. Either these two are same, so substitute in A place of B or B in place of A. So the rate of equation may be written as what should we do? Minus dj by dt equal to kAA equal to Ka square, or minus dB by dt equal to kBB or kb square. What should happen? I should because we have to take reactant A equal to reactant B, you know that. So in that we have second order reaction. What is second order reaction? dA by dt equal to Ka B. Yeah, okay. This is the second order reaction. In that we should take A equal to B. So either A or B. We should replace the, in place of A, B. We should replace in place of B, A. So what should we take? So dJ by dt equal to K of A. What happens? Minus dJ by dt equal to K A square. Okay, this is the with respect to A. With respect to B, we should try to equal to B. So what should take? Minus dB by dt equal to K B. What happens in that A position? We should replace B. So what should minus dB by dt equal to K B square. Okay, this is a KB square. Why should in place of replacement of A in place of B? So in that replacement of A in place of B. So this is the second order reaction replacements. Okay, these two equations. So since equation 1 and 2 have same, the kinetics of such reactions follow the similar trend as the followed by second order reaction having only one reactant. Okay, second order reaction having only one reactant. What is when the two reactants have different initial concentrations? So let us consider reaction A plus B. Yeah, we know that A plus B. Okay, products. So let the concentration of A and B at t equal to t equal 0 is A and B, and then concentration at T is A minus X and B minus X. Okay, what should take So let the concept what's on this when the two reactants have different initial concentration, let us consider reaction A plus B gives us two products. Okay, let the concentration of A and B at t equal to 0 is A and B, and concentration at time t is A minus x and B minus x. So minus dx by dt equal to k of A minus x B minus. Why should we take because in the we don't know initial reactants, what is A and B. We don't know what is the time required, what is the time happening. So which time happens we don't know. So what should we take? So initial and final time we should take. So at the time t equal to 0, we know that. So in that minus dx by dt equal to k into A minus x b minus x. Okay, in that minus dx by A minus x b minus x equal to k dt. So we know that minus dx by A minus x b minus x equal to k dt. Okay, in that first of all students listen about. So what should we take? Rate constant of second order reaction having two different reactants. First one, in general, the second order reaction of this type may be written as A plus B products. Okay, in such reactions, again there are two possibilities. When both the reactants have same initial concentrations, A equal to B, the rate of the equation may be written as minus dA by dt equal to k dA equal to Ka square minus dB by dt equal to kBB, so kB square. So in the term, since equation 1 and 2 are same, the kinetics of such reactions follows the similar trend as that followed by second order reaction having only one reactant. When the two reactants have different initial concentration, let us consider reaction A plus B two products. Okay, in that term, that the concentration of A and B at t equal to is A and B concentration at time t is A minus x and B minus x. So that minus dx by dt equal to k A minus x and B minus x. So in that what should we take? Minus dx. Okay, in that k A minus this A minus x B minus x take left side. Why? Because in this differentiation with respect to x, so in this also same differentiation we should differentiate. So A minus x B minus x. So this total value takes left side, and this dt takes right side. Okay, minus dx by A minus x B minus x equal to k dt. Okay, this is the equation. So in the term, on substitution, minus log A minus x by B minus x minus log B minus x by A minus B equal to kt plus I, or minus 1 by A minus B, and this is the order. So what happens? So in this differentiation we know that also. So what happens? Minus 1 by A minus B log A minus x by B minus x equal to k t plus I. Okay, with respect to t, so kt plus I. So where I is integration constant at t equal to 0 and x equal to 0, the value of I has been calculated. I equal to 1 by A minus B ln A by B. What happens here in that x equal to 0? So what should we? So minus 1 by A minus B log A minus x by B minus x. So k t plus I in that x 0. So what happens? T also 0. Minus 1 by A by B log A minus x B minus x equal kt. So in the term, what happens? Equal to 1 minus 1 by A minus B log A by B. Okay, this happens. Substitute the value of I in above equation. 1 by A minus B log A minus x B minus equal kt plus 1 by A minus B log A plus B. So what happens? I in this I we have to substitute this value. Why? Because this is the integration value. So this integration value substituted in this I place. So what happens? 1 by A minus B log A minus x by B minus x equal to kt plus 1 by A minus B log A by B. So take this side, 1 by A minus B log B into A minus x. So A into B minus x equal to kt. This total take left side. So what happens, this is log b into a minus x by a into b minus x, okay, equal to kt. So what happens, k equal to 1 by t. So this t goes to left side. What happens, 1 by t, 2.303 by ab. So this ln value is 2.30 into log. So 2.303 by a minus b log b into a minus x by a into b minus x, okay. This is the equation. In if one of the reactant is taken on a large axis, then k equal to 1 by t into 2.303 by a minus b log b into a minus x by a into b minus x. This is the equation. So what happens, this suppose a is in large excessive, so x and y may be negligible. K equal to 1 by t 2.303 by a. So in that a is negligible, so large excess. So in that b and x is negligible, so log ba and ab, okay. So 2.303 by a log b by what happens, b minus x, okay. This is what happens, k equal to 2.3035 a log that b a cancels, so b by b minus x. This is the equation, okay. What should we do in that on substituting, what happens on integration, minus ln a minus x by b minus c minus ln b minus x by a minus b equal to kt plus a. So in integration, log a minus log b is written as log a by b. So we know that. So minus what happens in integration, log a minus log b equal to log a by b. So this is the equation. This equation takes this side, okay. Minus 1 by a minus b log a minus x by b minus x equal to kt plus I. So where I is integration constant at t equal 0 and x equal to 0. The value of I has been calculated. So what happens, I equal to 1 by a minus b log ln a by b, okay. This is the equation. In that what happens, substitute the value of I in our equation. What happens, 1 by a minus b ln a minus x by b minus x equal to kt plus 1 by a minus b ln a by b. So what should we take, 1 by a minus b ln b into a minus x by b a into b minus x equal to kt, okay. Where did this takes this side, okay. What happens, this is why, because log a minus log b equal to log a by b, one method. So k equal to, in that t we can show, we should go to, in that t we can take in left side, okay. 1 by t into 2.303 by a minus b log b into a minus x by a into b minus x, okay. This is the equation in second order rate constant. So what happens, if one of the reactant is taken in large excess, then k equal to 1 by t 2.303 by a minus b log b into a minus x by a into b minus x, okay. We should take, so suppose a is in a large excess, so x and y be negligible. K equal to 1 by t 2.303 by a log ba by a into a by b minus x. What should we take, suppose a is in large excess. Large excess means heavy metal, heavy amount. So what happens, x and y may be negligible. X and y may be negligible, yeah. X and b also, x and y also negligible. Why? Because large in excess in a, so that's why this x and y and x and b are in small amount. So small amount cannot bear the large amount. So that's why these two x and y b are negligible. Why? Because it's a very a big amount and large excess. So that's why k equal to 1 by t 2.303 by a log ba by a into b minus x. So in that a cancel, b by b minus x. This is the equation of rate constant. So understanding students, what should we take, this we know that log a minus log b by log a by b. So in that where I is in the integration constant at t equal 0, x equal 0, then the value of I has been calculated as I equal to 1 by a by a minus b ln a by b, okay. Substitute the value of I in above equation, 1 by a minus b ln a minus x by b minus x equal to kt plus 1 by a minus b ln a by b, okay. You know that. So what happens for 1 by a minus b ln b into a minus x by a into b minus x equal to kt. So k equal to 1 by t 2.303 by a minus x log b into a minus x by a into a b minus x. If one of the reactant is taken in large excess, then k equal to 1 by t 2.303 by a minus b log b into a minus x by a into b minus x. Okay. In that, suppose a is in the largest excess, so x and y may be written as negligible. So this is the equation. Okay. So next one, evolution of k. In that, the value of k can be determined with the help of equation for So students, in that evolution of k can be determined with the help of a equation for which concentration of the reactants A and B at any given time, that is A minus x and B minus x are determined. So, and since the initial concentration A and B of the two reactions are known, the value of k can be easily ascertained. The value of k can also be evaluated graphically from which the quantity 2.303 log b into a minus x by a into b minus x here is plotted against time. The slope of time will be given the value of t. So what happens in the graph? What should we take? K value. This is from origin to straight line. Okay. This is the origin from straight line. Okay, this is the straight line. What should we take? The value of k can be determined with the help of a equation for which concentration of the reactants A and B at any given time, that is A minus x and B minus x are determined. So, and since the initial concentration A and B of the two reactions are known, the value of k can have easily be ascertained. The value of k can also be evaluated graphically from which is the quantity 2.303 by a minus b l log b x by b into b minus x is plotted against time t. The slope of the time will give the value of k. Okay, this is the graph. Okay, straight line. Next one, units of second order rate constant k equal to 1 by t time to moles per liter by moles per liter into moles per liter. What happens? So this moles per liter cancel. So or this moles per mole inverse liter, mole per liter, mole into liter inverse time inverse. What is the units? K equal to T inverse K equal to T inverse. What should happen? This cancels. So what happens? Moles per liter, liter per mole. So liter is mole inverse. What? This cancels. So what happens in this? So 1 by T into liter by mole. So what happens? This is a time inverse, mole inverse, liter. Okay, this is the second order reaction. Okay, student. So half-life period of a second order reaction. What happens? Substitute x equal to a by 2, t equal to t of. Okay, we know that. So what happens? K equal to 1 by t x by a into a minus x. So k equal to 1 by t of a by 2 minus a by 2 into a by 2 minus x. Okay, what happens? T of equal to 1 by t, 1 by k, a by 2 into a by 2 by into a minus 1 by 2 equal to 1 by k, a by 2 by a square by 2. Okay, what happens in this one? Same like this. What happens? A by 2 by a into a by 2. So in this a by 2, a into a square. So next one, a by 2. This a by 2, this a by 2 cancels. What happens? A by 2 by a square by 2. So k into 1 by, so 1 by a equal to 1 by k. This is the second order reaction. So what happens in this one? So half-life period. What is half-life period? Substitute x equal to a by 2 and t equal to t half. So k equal to 1 by t, x by a into a minus x, k equal to 1 by t half into a by 2 into a by 2 into a by 2 minus x. So what happens in this? A by 2 a square. Okay, what happens? T half equal to 1 by k, a by 2 by a into a minus 1 by 2 equal to 1 by k, a by 2 a square by 2. Okay, this is k equal to 1 by, so what happens? T of equal to 1 by k, a by 1 by a, so equal to 1 by k. This is the half-life of second order rate constant. That is the evolution of k.